Good morning. Today we are solving absolute value inequalities. So we spent the last 3 days solving equalities with equal signs. Today we're going to have inequalities. So we're going to have the symbols less than, greater than, less than or equal to, or greater than or equal to, and see how those affect absolute value expressions. So let's just think about what we've been doing these last few days, and we have x, absolute value of x equals 5. And remember, on that number line, if we're at 0, we're saying we can go 1, 2, 3, 4, 5. And so we're at this number right here. 5 is 5 steps away. And it also means we can go 1, 2, 3, 4, 5. And -5 is also 5 steps away. So we have two answers. We can put in a -5 and a +5 to get 5 steps away. So what does this mean? So if we just look at this first one and we just write it as is, x is less than 5. So what kind of numbers can we put in here to be 5? Well, we can't put exactly 5. Remember, we have to have an open circle. But what about 4.9, 4.8, 4.3, 4.2, 3.3, 3.1, 2.5, 2. Do all of these numbers fit? So can I go this way and does it work? Okay, even the number -6, is -6 less than 5? Yes, it is. But remember, we always have to have two cases. Like in this situation over here, it is the number -5 and it is the number 5. We have two answers. On the number line, it would be a solid circle at 5 and a solid circle at -5. Nothing shaded in between, nothing else. It's just these two numbers, 5 and -5. Well, when we're talking about x is less than, we're talking about a lot of numbers. So remember, we have to also fill in, remember there's always a second case. So we have x compared to -5. And remember, in the last, when we were solving our just inequalities, whenever we divided or multiplied by a negative, we have to flip our sign. So when we do this here and we write the opposite of 5, and we write the -5, we have to flip our sign. So I have x is greater than -5. Okay, so if I go down here on my number line, 1, 2, 3, 4, and I'm at -5, again, this is an open circle because we do not have the line underneath it. Now it says any number bigger. Well, let's think about this. If we're taking the absolute value of something, can't we put in a -4? What is the absolute value of a -4? The absolute value of -4 is 4. Is 4 less than 5? Yes. So this number right here, 4, has to work. Well, what if we put in -4.5? What's the absolute value of -4.5? A +4.5. So isn't that smaller than 5? Yes. Well, what about 3? The absolute value of -3. The absolute value of -3 is 3. Is 3 less than 5? Yes. And how about a -2? What's the absolute value of -2? 2. Is 2 less than 5? Well, what if we just put in a +2? What's the absolute value of a +2? 2. 2 is less than 5. So now what if we put in a -6? What is the absolute value of a -6? 6. Is 6 less than 5? No. That's why we do not have this number -6 as one of our answers. So you see where we end up shading? We end up shading between these two numbers because any of these numbers work. -1.1, +1.1, 1.8, -1.8. So we pick the numbers that are between -5 and 5. Now, this should also click something else in your head because remember when we were graphing our inequalities, we had them ands and ors, our compound inequality test. And remember, in compound inequalities, ands were always shaded between. So do you see how we have the letter and less than and we shade between? Okay, let's try another one. All right, so this is where we have less than or equal to, and you can see where it is shaded between. That is like an and problem that we were just doing in the compound inequality. See how it says and see how it has less than x? All right, so here we go. Absolute value of x. Ooh, we flipped the sign, and now it's bigger than 5. So we have x is greater than 5. So on our number line, 1, 2, 3, 4, 5, any number bigger than 5. So doesn't 6 work, 7 work, 8 work, 9 work? Again, it's an open circle, and we shade to the right. Now, are there any other numbers that we could pick to put in here? Like, can you put a 4 in there? Does it work to have 4? Is 4 bigger than 5? Nope. Okay, and that's why we don't have 4 shaded in. How about 2? Is 2 bigger than 5? 2 right here. Nope, that's why it's not covered in. Well, let's just pick a negative 10. So if we have the absolute value of negative 10, does that work? So way down here, negative 10. Does that work? Should I be coloring that in on my number line? Well, what's the absolute value of negative 10? 10. Is 10 bigger than 5? Oh, yes it is. So 10 has to be colored in. What about a negative 7? Is the absolute value of negative 7 bigger than 5? Well, what's the absolute value of negative 7? 7. Is 7 bigger than 5? Yes. So I have to color in this negative 7. Okay, what about negative 3? Is the absolute value of negative 3 bigger than 5? Well, the absolute value of negative 3 is 3. Is 3 bigger than 5? So this number 3, no, negative 3, I do not want to color that in. So where do I go to? Well, you know how we always have to have 2 cases? Well, I haven't written my second case yet. So my second case is going to be x. Now remember what I just said. When we're going to write the negative 5, we have to flip this sign. So instead of it being greater than, I have to go this way. Okay, so from negative 5, it is going to be here, negative 5, open circle, and I'm going to shade this way so that I pick negative 11, negative 12, negative 13. So I'm shading all the way out. What kind of problem does that look like? If and was shading between, do you remember in our compound inequalities? Didn't our ors go out? Okay, so greater than is like an or problem, and we shade out. Let's see if that happens again in some more problems. All right, let's try this one. Okay, 2 cases, always 2 cases. X plus 3 is greater than 7, so I'm going to subtract 3. So x is greater than 4. Okay, here's my 0. At 4, is that open or closed? I think that's going to be open. There's no line underneath it. And greater than. Okay, now I always have to do my second case. So I have absolute value and then my symbol number. So I can go right to my second case. X plus 3. Now remember, we need to flip that sign and make it negative 7. So I'm going to subtract 3, subtract 3. So x is less than, use your calculator so that you do negative 7 minus 3, and we get a negative 10. So I'm down here at negative 10. Again, open circle because there's nothing underneath. And I am going to shade to the left. Okay, well, what did we just say? If this symbol originally was a greater than in here, that it was going to be an or problem, and we would shade out. That's exactly what happened on this previous problem. Here, we had a greater than symbol in here, and we shaded out. Okay, that's exactly what happened here. Greater than, shaded out. It's an or problem. All right, let's try this one. Okay, the first thing I noticed is you guys see how the symbol now went to less than or equal to? Less than or equal to, this means an and problem, and I know when I'm shading, it's going to be like this, and I'm going to shade between. So let's see if that's what happens. So first case, x minus 4 less than or equal to 10. I'm going to add 4, add 4. So x is less than or equal to 14. Now at 14, is that an open or closed circle? Because it has a line underneath it, I'm going to close this circle. I'm going to shade to the left. Okay, second case, because it's already absolute value, symbol number, so I can go x minus 4. Remember, flip the sign and make that negative. So I'm going to add 4. Add 4, so x is greater than or equal to negative 6. So down here to negative 6, line underneath, equal to, so closed in. And it says any number is greater than. So we shade bigger, and see how those two are going to be crossing? Just like we said, when it's less than, we shade between. Remember, these are like your ands and your ors. So if you have your notes, ands are between, ors shade out. Have that in front of you. Now we can add the symbol to it that or is greater than or equal to. And by the ands, you can put the less than or equal to sign. Well, this problem's already solved. Let me just erase it here so that we can start over. So what we're going to do here is there's an error here, and this is supposed to be a plus sign, not a minus sign. So I am going to just get rid of that. That's a plus sign. Okay, so let's set these up. So we have 5x is less than 30. And we're going to set up 5x is greater than, remember we flip it, and it is a negative 30. Okay, so we solve this by dividing by 5, dividing by 5. So x is less than 6. So on our number line, at 6, we are going to have an open circle, and we are going to shade to the left. Okay, when we go to the other one, we are going to divide by 5. And we have x is greater than, we do not flip, even though we're going to get a negative answer. Remember, we divided by a positive, so we leave our sign the same, and we have a negative 6, and it's an open circle because we do not have a line underneath, and we shade to the right. Okay, less than, and we shade between because that is like an and problem. Okay, so let me just try to quickly squeeze in another one here. And if we have the absolute value of 2x minus 1 is greater than, let's just say a negative 9 or a positive 9 here. All right, so to solve that greater than, we're thinking it's going to go out because it's an or problem. So our first case is 2x minus 1 is greater than 9. And the second case is going to be 2x minus 1 is less than a negative 9. So we flip it and make it negative. All right, let's solve this. Add 1. So it looks like we have 2x is greater than 10. Divide both sides by 2. And x is greater than 5. So at 5, on our number line, it is going to be an open circle, and we are going to shade to the right. Okay, over here, we're going to add 1, and use your calculators so that you take negative 9 plus 1 is a negative 8, divide by 2, and x is less than negative 4. Okay, we did not flip our sign because we divided by a positive number. So at negative 4, it's going to be an open circle, and we shade to the left. Just kind of we thought, greater than, and so it's an or, and it shades out. All right, good luck on your inequalities homework.